Okay, so we have now number 15. So the sum of the expression we are given expressed as A or B, and we want to find the sum of A, B. So like this is an interesting question, but this is also one of the common topics we've seen a lot in the AMC so far. So it is like telescoping stuff. So because it goes forever, and then I like to write this expression in terms of difference of some fraction. But before I kind of get into this one, maybe I should remind something. So if I have, let's say, 1 over n times n plus 1, and then a lot of math people know this already. This is equal to 1 over n minus 1 over n plus 1. And then that's something we've seen, because if you actually simplify this one, you end up getting this one. But the difference was 1, so we got this one. But if you have things in the denominator like n times n plus, let's say, k, we can actually write something similar to this one, but I'm going to write this as 1 over n minus 1 over n plus k. But when you simplify this, let's say if you multiply this by n plus k and then multiply this by n, so you got n plus k minus n, the n's will cancel, you got k extra in the numerator. So which is why it will not be equal to 1. So to make that 1, so we divide this by 1 over k. Now these are going to be equal to each other. And then these are the two things we've seen a lot, but that's how we try to make this a bit nicer. But let's ignore this for a second. I'm going to clean this mess first. So I can pull the k as a factor. So if I do that, so you get k times k times k squared plus 6k plus 8. And then this is also factorable. So that should be k times k plus 2 and k plus 4. But, in this example, we had only 2 things to multiply, but now we have 4. But we can still use the same logic. So let's try to see if we can use that. So I'm going to write as 1 over k times k plus 2 and minus 1 over k plus 2 times k plus 4. So like when I do simplify this one, you are going to multiply this fraction by k plus 4. So the numerator will be k plus 4 divided by the product of those 3 factors. And then when you multiply this by k, you get k. K plus 4 minus k will just give us 4. But I need that to be 1, so which is why I'm going to divide this by 1 over 4. So that means this expression can be written as 1 over that. So I hope that was clear. And now we are going to kind of use this separately, because we have the same idea as this one. So if I want to take the first one, like 1/4, and then that will be 1 over k minus 1 over k plus 2. But this is going to be also, the difference is 2, so which means we're going to have 1/2 as a product. So I'm going to say times 1/2. I can pull it outside. And then minus, it has the same story here. So you will get 1 over 8 times 1 over k plus 2 minus 1 over k plus 4. Okay, so then I just want to take the 1 over 8 out of the sum notation, so I can just deal with that later. And then when you write this as the difference of these two, so you got 1 over k minus 1 over k plus 2, and then minus the 1 over k plus 2 minus 1 over k plus 4. Again, it's starting at 1 and all the way to infinity, so I can just write those. And then this also has 1 over 8, so I'm going to pull that as a common factor. So you don't really need to write this in the test, to be honest, to save your time, so you can just go from calculation stuff. So let's see what we have now. So we are going to plug in the numbers. Like if you start with 1, so you get 1 over 1 minus 1 over 3. And then if you plug 2, so you get 1 over 2 minus 1 over 4. And if you do 3, so you got 1 over 3. And then you got 1 over 5. I'm just writing a bit more so you can see the cancellation. So 1 over like 4 and 1 over 6. So that was the first one. And if I want to use the second one, you can do the same thing as well. But with this, these will cancel. And then you do get like cancel with that one. So you end up getting 1 and 1/2. So then the next one will be like, if I want to choose the, what was the last one I chose? That was 4. If I choose 5, so 1 over 5 minus 1 over 7. So that 1 over 5 and 1 over 7 will cancel. So all these will cancel. So you're going to have only these two left over from this guy. Okay, so that's cool. And then if I want to do the same thing with the second one, so you get the, let me use that. So choose 1, so you get 1 over 3 minus 1 over 4. And then if you choose like 2, so you got 1 over 4 minus 1 over like 6, right? Actually, this was 5. When you choose k is 1, so that was 5. And then next one is like 3 for k, so you got 1 over 5 minus 1 over 7. So this will cancel. And then if you want to do the one more just to see what's being canceled, so I choose 5. I choose like 1, 2, and 3. So if I go with 4, so you got 1 over 6 minus 1 over 8. So that means this will cancel. And then if you keep doing this, the remaining will cancel because it goes forever. Only terms that is left over is these two. And then in this one, we got only 1 and 1/2. So let's clean these a bit. So I'm going to kind of take these out of the way. So like if I want to not miss anything, I hope. So I'm going to take the 1 over 8 times 1 and 1/3. So which is going to be 3 over 2. And then minus, because there was a minus here, so 1/3 and 1/4. So if you add those, like 1/3 and 1/4, you get 7/12. So that should be 1/8. So you get, if I multiply by 6, that should be same denominator, so 18 minus 11, that's 11. So that should be divided by 2, 12. So in this case, 11/96. So this is my fraction. So we are looking for a plus b when they are relatively prime, which they are. So 96 plus 11 is actually 107. So this was like number 15. I think it's reasonable for this problem. But as soon as you know, this is a like telescoping series, the rest is actually not too bad. But anyway, so that was number 15.